Hello, and welcome to Exploring Axon, a podcast where we discuss Axon Framework, Axon Server, and their ecosystem. I am your host and a software developer at AxonIQ, Sara. In this episode, I sat down with our CTO and co-founder, Allard Buijze, to talk about our newest feature of Axon Server tiered storage. Allard explained the difference between the various types of nodes that we currently use in Axon Server with tiered storage and how they can complement one another. I hope you enjoy this conversation, and let's have a listen. Hi, Allard. Welcome back.
Hi, Sara. Good to be back.
Thank you. It's my very first time recording in person with another guest, so this is going to be fun. Today, we want to talk about one of the features that's coming up, which is tiered storage. Probably having this feature come up in Axon Server, I'm assuming at some point in Q1.
That's the plan indeed, yes.
That's the plan, great. So before we get to tiered storage itself, let's start by talking about different nodes. We do have various nodes that are used within Axon Server, primary node, secondary, and backup. Can you explain the difference between each one of them, and why have we decided to use various types of nodes when using Axon Server?
So the idea of those nodes is that when you have a cluster of Axon Server, very often that cluster will store the data that is the single source of truth, or at least the source of all information in various systems. So keeping that data safe is really important. So besides a typical 3-node cluster, if you will, of primary nodes, we very often have additional nodes that have extra copies of that data to make sure it's safe. Right? If something happens to the primary storage for whatever reason, you always have a backup somewhere else. So very often those backups are placed in another region in another data center. So it doesn't directly affect the performance of the primary nodes. There's no additional latency, but still you have your data far away, so that it will survive a fire, for example, in the primary data center, which unfortunately every now and then does happen. So it's good to come prepared.
Right.
So we have these various roles, if you will, because a node in itself is not a primary or a backup. It's always a primary or a backup in the context of a context,
right.
Which makes it nice. So you can have a large cluster, a multi-regional cluster, and have the primary nodes in one region and the backup in another region, as well as the other way around at the same time.
Right.
So that said, there's a couple of roles. Now, the most important one is the primary nodes, and the primary nodes are the nodes that are responsible for basically handling all of the transactions. They typically connect to your applications. I say typically because you can choose otherwise, but and they will manage the transaction. So a transaction is only acknowledged when the majority of the primary nodes has a safe copy of your data. Right? That's when we consider a transaction complete. Then there's backup nodes, and we actually have two types of backup nodes. We call them passive and active backup. So the passive backup is just a node that would look at the primary nodes and basically copy all the information they see going there. So every time a transaction is acknowledged, it is also replicated to the backup node. But the primary nodes will just move along. If the backup node doesn't copy the data for a while, it's fine. The primary nodes will just continue working. So there's no guaranteed backup at any time, right?
Okay.
It's a best effort kind of backup. In some situation, best effort isn't just isn't good enough, right? We want better effort. Never mind.
Best is better than better, but
usually best is better, but sometimes you want better than best,
you
right? You want
bestest, exactly.
Bestest effort, or you want guarantee, which is slightly stronger. For that purpose, we have active backups, and like everything in life, they come with pros and cons. But the difference with an active backup is, in that case, a transaction for a pending event is only acknowledged if at least one active backup has the transaction as well. So you have a guarantee that your data is not only on the primary nodes, but also at least on one of the backups. So if those backups are in remote areas, you'll know that at least one of the two remote areas has the data, which gives you a lot of security for data availability, that you're not going to lose it. But those nodes have to be active, because as soon as they cannot be reached, then transactions cannot be acknowledged, right? Because there's this rule that they have to be replicated. And that's why typically active backups, you will have more than one. So that when one connection is lost, the other one can take over. So that's for the, let's say, the main roles and how they manage the data. And then there's a very special one, which we call the messaging only node. It is basically a node that does not play along in the transactions. It is just there to allow connections of applications, and it can be used if you have large scale communication around commands and queries, which is fine, but you don't need all of those nodes to also hold a copy of that data. And I wanted to keep the best for last, which is the secondary node. So a secondary node is very similar to a backup node in the way that it behaves. Actually, the way it copies the data is exactly the same as a backup node. But there's a little bit of a difference in how the primary nodes react to the presence of a secondary node. So while a secondary node keeps a real-time copy of all the data that is on the primary, at some point the primary nodes may decide that they don't need a copy of the data anymore. Right? So unlike a backup node where that just keeps an exact copy of the primaries, a primary node may decide to remove data locally as soon as it knows that the secondary nodes have it as well.
Okay.
And when that data is requested, the primary node knows that it needs to go to the secondary node to actually fetch that data. So it's kind of like a backup node, but with the purpose of allowing these primary nodes to remove the data, which is very useful if you have a lot of data. If you have, for instance, a 3 or a 5 node primary cluster, you'll have 3 or 5 copies of all the data. That might be a lot of data, and then a lot of copies of that data, which just means you've got these events of a couple of years old, and they're just sitting there 5 times,
taking up space,
taking space, exactly. Putting their share of the bill. So with the secondary nodes, you can choose to have only one secondary node, and then just accept the fact that some data may not be available if there's a network problem with the secondary node. Right? And that might be perfectly fine. If you say we keep last year's data on the primary and then older data just on one copy of a secondary node, then it's significantly cheaper in terms of storage.
So with great explanation, thank you. So with all of that, we have talked about the reasons why we choose basically an odd number of primary nodes. But can you kind of recap that real quick? Because you mentioned typically there are 3 primary nodes. Can you explain a little bit why we choose that route, and what kind of benefit does it have if one of them goes down?
Yeah, so the reason it's an odd number of nodes is, so the type of data that we store is the very important data. Is very often the source of information that is used for various different systems. So we really want that data to be consistent. We want to guarantee the consistency of that data. Now, when you look at the CAP theorem, basically it tells you that when there's a network partition, so when there's a communication problem, if you will, between nodes, you can only either guarantee availability, so either you can access the data, or you can guarantee consistency. So either the data is correct or it is available to you, which is a pretty big dilemma, right? We have very strongly chosen for the consistency side because of that source of truth, right? Mm-hmm. If we cannot guarantee the consistency of the data, we prefer not to serve the data at all.
Yep.
But yet we do want the ability to lose a node, right? To have a problem on one node, or to be able to take it down for for maintenance or an upgrade or whatever. There's just several reasons why a node would not want to move on. So what we do is we use the RAF protocol, which is a very popular protocol these days for replication, and it can guarantee that consistency for you. And it needs an odd number of nodes so that you always have a clear majority. Mm-hmm. If there's a communication problem between two sides, if you will, then one side is always larger than the other side. Gotcha. And the larger side can then continue processing, and the smaller one can basically will effectively stop. So in a 3-node cluster, you can lose one node. The other two still have the majority, so they can still safely process transactions. Whereas in a 5-node cluster, you can even lose 2 nodes, because then the 3 remaining nodes are still a majority. So as long as in a 3-node cluster, one node that is accepting a transaction can get a confirmation and acceptance from one of the other two, then we're safe. And that's why we...
And one thing that you mentioned that I like to highlight is the fact that one of them can be down for maintenance purposes. So the availability is always there. Therefore, you never lose track of your data, and you don't have to worry about taking the whole system down for, let's say, overnight to do maintenance on it. So that means that problem is solved right there.
Nightly updates. There might still be a minor impact on connected applications. Obviously, when you take a node down, there's a slight window in which applications need to connect from the node that was going down to the new ones. Right. But we do have graceful shutdown. Applications are notified of a node going down. So typically, it's a very brief moment in time where these disconnects happen. So that will never give you 100% availability, but at least you should be able to get 3 or 4 nines using that. Yes.
Cool. So now let's move on to the topic, which is tiered storage. Can you tell me what tiered storage is and why should I care?
Yeah, exactly. Well, why? I'm also wondering why we didn't have it earlier, but that's
why did we take the longer route to get there?
So we introduced secondary nodes to manage the data volume, right? But then what we found out is even on the primary nodes, you can have a lot of data. I gave the example earlier of storing 1 year of data on the primary node. Well, even if you do that, that might be a lot of data. And we had this challenge where customers sometimes had, or still have, because it's not released yet, but they have a challenge of choosing where to store the data, because SSDs are really fast and nice, and they can do they can concurrently access multiple parts of the data, writing for one, reading from another, which is fantastic for the very recent part of your event store.
And they come with a cost.
But they come with a cost.
Little
exactly.
Bill.
So they're fine for a few dozen gigs, maybe a few hundred too. But we have customers with several terabytes of data. And then, with that volume, you have another problem or challenge, I would say, is that even the cheaper disks start becoming very expensive at that point because you need the large volume. So you can use NFS, and NFS is very scalable because it will just use several physical storage devices and it will put a network layer on it. But NFS is not cheap either, and very often you pay for the bandwidth, which could be significant. Right. So we wanted to find a way to better manage the data that is available on a single node of Axon Server. So you can choose to store data that is recent on a fast storage, but maybe slightly more expensive. And then to prevent it from growing too large, we can store other data on cheaper disks that are maybe larger but also slower. Mm-hmm. And this is exactly what tiered storage does. So you can basically see it as a type of sharding, except that sharding is typically just across different storage nodes that are considered equal. Whereas we do sharding based on the age of data. So in an event store, you basically have a time series of data, and the most recent data is the data that's where you write. But that's also where most of the reads will happen. Right? When doing event sourcing, you're going to probably read from the more recent events than
something from 10 years ago.
Yeah, exactly. Right. Events of 10 years ago, there's probably a snapshot to prevent that from being loaded. So what we do is we store everything on the first tier is what happens. And then at a specific configured, it could be an interval, it could be a size, those data segments that we use to store the data are moved to the next tier of storage.
Which I'm assuming is a slower...
Which would be a slower disk, a disk that is maybe more optimized for sequential reading or can just store a large volume.
So still kind of similar to secondary nodes.
There's some overlap between how that happens, except that this is on the same node. So it is still we're still talking about a primary node or maybe a backup node. And the fun thing is you can choose a different strategy for primary nodes and backup nodes. So backup nodes, they typically don't need the same SSD kind of access, where you don't load that much from a backup node. It's just trying to follow along. So it just needs to be able to write. So it's probably fine to store everything just on a regular disk. Whereas with primary nodes, there's a lot of transaction activity going on. So you probably want that first disk to be fast and very close by. So you want the physically attached disk. And I mean, different cloud providers use different terms for those disks, but you want something close and fast for that. And the thing about tiered storage is that you're not tied to, so unlike, for example, secondary nodes, you only have primary and secondary. But with tiered storage, you can choose as many storage tiers as you want. So you can really, it's not just from SSD to other disks, but you can have multiple disks. So we have customers managing terabytes of data, and when you talk about is the data still valuable? Can't you just get rid of the data? They stare at you like, don't touch the data. We want to keep it, but we just need to be able to manage it slightly better. So if you really want to keep the data around, you can choose several tiers of the same type of disk just to be able to spread the data across different disks.
So a couple of questions on that. The first one, so you mentioned that you can keep all of them on the same node. With that said, then I'm assuming that the 3 primary nodes that you're using would use similar configuration for the tiered storage, or is that not a requirement?
So right now, the way we've implemented the first version, or as it will be available in the first version of this feature, is that you can configure the different, let's say, storage classes. So by a name. So first we store it on this class, and then on that class. And per node, you can choose, okay, this class, which disk is it exactly? So yes, you can have a different one per node, but there's one configuration for all the primary nodes. There's another configuration for backup nodes. For different roles, you can have different configurations. Typically, as I said earlier, on primary nodes, you have this, you want to have fast transactions, so you probably choose a class that then is mapped to an SSD for the recent events, right? Which is maybe only the 10 gigs, right? You can 10 gigs of very fast disk is not that expensive. And then after the 10 gigs, you store the next 100 gigs on a somewhat cheaper disk. And then the several terabytes later could be even stored on a very not so local disk somewhere else that gives you much cheaper access. So you can choose these different classes, and then you can map the classes to disks on every node in the configuration.
So with that said, you did mention that with the typical usage of primary nodes that we currently have in place, the data is basically exactly replicated on all of these 3 nodes. However, with the tiered storage, where you can have different configurations of where the data is stored on each one of these primary nodes, how do you then replicate the data exactly? Does that make any difference then?
So the replication process in itself doesn't really matter. So there's still one configuration of all the classes, right? So you store 10 gigs in the first tier, then it moves to the second tier, and then the third one. While the tier may have a different disk it will have a physically different disk on all of the nodes.
Right.
but they still contain exactly the same copy of data.
Okay.
But they might store that copy on a different place than the other nodes. But they will still have, so all the events are still available 3 times. So if you have a 3-node primary cluster with tiered storage, you will still have 3 copies of the data. The only thing that's changed is where that copy is, where that particular event is stored.
Mm-hmm. So whether it's on a slower, basically, disk versus a faster one, that can
Correct.
be different. Okay, great. There is one feature in tiered storage that is quite desirable, I think, by some of the customers, which is the usage of what we call the black hole for the ephemeral events. Can you explain what ephemeral events are, first of all, and why did we decide to basically bring in this feature of black hole, which I'm sure you will explain what it is, and what kind of usage do we have in real life examples?
Yeah, so indeed, ephemeral events is a difficult topic to talk about in the context of event sourcing. But
do tell why, because we
you,
want to keep the events forever, but now we're talking
exactly,
about ephemeral, which is not forever.
Let's get rid of those events. So of course, there's a time, 20 years from now, what's the value of those events? And I think there's not a lot of arguments about that. So forever is an approximation, right? So it's usually a little bit shorter than that. But with the ephemeral events feature, we're really talking about keeping data for a significantly more limited period of time. And that's because we've noticed that not every context really needs to store all of the data that long. There are situations where, for example, if you do a type of transaction processing where transactions typically take, or business transactions I'm talking about here, when they take about 5 to 10 minutes, then after a year, nothing's going to happen to those transactions anymore. So what's the value of keeping them even longer than 5 weeks? Now, there's a lot of places where they do want to keep that, and the system is still designed to do that. But with tiered storage, there could be one storage tier, and of course, it has to be the last one, which could be the black hole.
Yeah.
That's well, you might have heard of them in outer space. Things go into it, but we don't really know where they are, or what happens to them. So we basically, you can put your events there, and then they disappear, and then are nowhere to be found anymore.
Nobody knows what happens to them.
Nobody really knows what happens to them, and we always internally joke that even our support engineers will not go in there to see if they can be,
because they won't come out,
because they'll probably not come back. So events that are there, they stay there, and they will never be found. You can see it as the dev null disk, right? It always has space. You can always write any file in there that you want, but don't expect it to come back. So yeah, black hole is one of the terms that we've used for that tier. We'll see what it's called when the release comes out, but it's either black hole or dev null, or
something to that effect, just to where things go to get lost.
Yeah, and you don't want to be never retrieved again.
You don't want to touch it with a 10-foot pole. So that's great. Now with this option, now you did mention that some business transactions you don't need to keep track of them for a long period of time. Can you give me a couple of examples as to what those business transactions might be?
Yeah, so in some cases we've seen payment processing systems that just process a bank transfer from one account to another, and then all the technical things that need to happen for that transaction. That typically doesn't take longer than a couple of seconds. Right. And then they don't always need the events themselves for auditing. There was an existing auditing system in some of the cases that we've seen. So everything is replicated to that auditing system, and they don't need the events anymore. So instead of paying the penalty of just keeping the events around because event sourcing says, store everything forever, if it has no value, or if the value of the events is not higher than the cost of maintaining them, then just get rid of them.
Yeah.
And another one that we see very often is when you have a multi-context system, there's always some communication between these contexts.
Right.
And a pattern that we see very often is that they create one extra context, which is the integration context.
Yeah.
And that's where events go that are worth sharing outside of your own context, your own bounded context, if you will. So typically, contexts outside of your own, they don't care about all the nitty-gritty details, because with event sourcing, every change is an event,
Yeah.
right? Even if it's a small change, and it might be completely worthless to other contexts. So you want to share a copy of an event, which we usually call milestone events, right? Something happens that is slightly more significant than all the other things, but those milestone events, they would then carry a bit more information so that they're also useful to the other context. But as soon as the other contexts have responded to those events or reacted and done whatever they needed to do, the value disappears again.
Mm-hmm.
Replays, well, you probably don't want to always be able to replay for a year in the past, right? Maybe those integration events for the last 3 months are enough. So in that case, what you can do is you can set up this storage tier to have a primary storage on some disk that matches the requirements of your transactions. And then say after 3 months, the data segments are moved to the black hole, and then they just disappear.
Go away.
Right?
Yeah. So I think it's worth double mentioning that it's not only shorter transactions, but more importantly, business value. If it's not worth keeping, just get rid of it.
Exactly.
Perfect. Yeah. Now, how can the tiered storage complement what you explained about primary, secondary backup nodes? And a follow-up question to that, do folks have to pick one or the other, or they can just use them as is, or is there a preference? Or I guess it all depends. I can already see you saying it depends for all of the above.
It always depends. No, actually, we found out it doesn't really depend.
Excellent.
Finally, for
I never
once.
thought this day would
it's
happen.
It's not a DDD related question, so I guess we're good. Yeah. Now the thing is, when you especially when you talk about ephemeral events and tiered storage, the pattern sounds very similar to what you had with primary and secondary storage, right?
Exactly.
The primary moves data to the secondary, conceptually at least, and then it disappears from the primary. There is a big difference, though. There's a couple of differences. So tiered storage is about the storage location for a single node. So it is still a primary node or maybe a secondary node. So it is still the primary node that has all the data. So you still have 3 copies of the data if you have 3 primary nodes. It's just that some of the data is on one disk and some of it is on another. The other difference is that with primary and secondary nodes, the data is managed by a different node altogether. So it's really so it really changes the number of replicas that you have, right? So if data is removed from a primary node because it is stored on a secondary node and old enough to just leave it there, the data is still available to the primary node indirectly. So there's a little bit of added latency, makes it slightly more expensive. But more importantly, you've deleted 3 copies of the data and have it replaced by, for example, 1. Or if you have a 5-node cluster, it's even more dramatic. You're deleting 5 copies to just retain 1. So the total amount of data is reduced that you store. But if you have a lot of data, now your primary is nice and happy, right? Because after, let's say, 100 gigs, it might be able to say, hey, I don't need that data anymore. Just get rid of it because the secondary node has it just in case I need to retrieve it. Meanwhile, that secondary node has all the data. Where does it leave that data? So tiered storage is then a very powerful feature within those secondary nodes to say, hey, we want to keep the data on different disks. It just moves from one to the next disk as soon as
And
certain limits
sometimes
are reached.
ultimately it
Right?
just goes away.
And ultimately, yeah, you can tell the secondary node that, hey, you store the data, but after 7 years, just send it to the black hole, because even the tax authorities are not interested in your transactional data anymore. Then probably it's really irrelevant.
Keep it for 10 years in that case.
10 years, depending on the jurisdiction.
Right.
There's some countries that require it for 10, some 7. Medical data is very similar. Very often has a retention requirement as well. GDPR has a lot of rules about retaining data and tracking, being able to track decisions.
Yeah.
So make sure that your configuration complies with those regulatory requirements.
Exactly.
So I think that so while at the office we had those discussions as well. Hey, does this make secondary nodes obsolete? Mm-hmm. But I think it is a very nice feature, especially for those secondary nodes. To be able to, it complements it, and it allows you to manage the large volume of data that a secondary node may need to manage.
So at the beginning, we kind of made a half joke, half serious comment, which was, why didn't we do this in the first place? Was it because at the time we didn't necessarily think of these requirements, or business decisions were not as crucial, I guess? And now we've seen more cases where the feedback was, hey, we really don't need to keep everything. Let's get rid of some of it. Was it the first or the second, or maybe the combination?
It's actually the combination of the two. So we started off with primary and secondary nodes. Well, obviously we started with primary nodes, but we added the capability of secondary nodes to allow to manage that data, right? You can give the secondary node a larger disk, but also a slower and cheaper one. So we started doing that, but as as you get more customer feedback, you start noticing that, hey, these customers are doing a lot of transactions. They're not talking about thousands of events per day, but they're talking about thousands of events per second, continuously all day long. And then it's like, every day we store a certain number of gigs of data, right? So they monitor disk space, and they can mark a day on the calendar not too far away where that disk is getting full. So we needed something to manage that large volume of data. And then we also had this pressure from our users to get rid of certain events, because the value compared to the cost of storing it was
just doesn't make sense.
Didn't make sense, right? And then we really wanted to find a solution for both the problems. We really like to look at different problems and really find that what is the smallest thing that we can do that can solve all of these problems. In this case, it was the tiered storage, and just say, hey, one storage tier, and obviously it's the last one. Could be the black hole, where we just say, okay, it just disappears into it. It's once it's drawn into it, it's gone.
And one thing that you did mention while you were explaining in various parts, but I'd like to ask, just to be concrete on that. I'm assuming that all of these tiers are configurable, so you can go and decide which, not necessarily the tiers, but the events, as to which tier they go into, and then eventually which one of them will be transferred into that black hole. Is that correct? You can configure everything, or is it kind of set automatic or as default in some cases?
There's definitely a lot of configuration you can do. The configuration you can decide on is what is the first tier, what's the second, what's the third, and what are the rules for moving data from the first to the next one.
Okay.
And those rules are either time-based, so data has to stay on a certain tier for a certain amount of time. And then as soon as the entire segment is older than that, so if there's no events younger than that particular time frame, then it is moved to the next tier. So it's either time-based or it's size-based.
Okay.
So you can say, I want 10 gigs of data on this storage, and as soon as a new segment is created that would overflow that amount of data, files will be moved. Right.
Okay.
So you always need to make sure that if your disk is 10 gigs, don't set it at 10 gigs. You
Okay.
have to have a little bit more. Mm-hmm. Because there's some safety measures in there that if the disk is we've seen situations where disks are not available because sometimes they're not physically attached, but they're network disks. So we want to make sure that the data is copied to the new disk, then it is validated, and only when it's validated, it's removed from the prior storage tier. So there's a little bit of time where the events exist in two places. Of course, Axon Server knows that; it will manage that, so you don't read events twice. But again, that data consistency is so important that we want to make sure it safely made it to the other side before we remove it. The black hole being one exception. We're not checking if it safely made it into it.
No, nobody goes in there.
Nobody goes in there. Yeah. So that's configurable. At runtime, you can still change some of that configuration. For now, we only allow changes at the very end of it. So you can add new storage tiers behind it. We are looking at algorithms to allow you to change the configuration altogether, so we can calculate where every file needs to be in the new configuration. But that may, in some cases, cause more data moving around that you would anticipate. So that's something we want to get a clear picture of before we actually provide that as a feature. So for now, you're allowed to change the configuration. You can add more tiers after it if you want. Yeah.
So you did mention size base or time base. Is it safe to also assume or state that for certain events that they don't have the business value to keep into your event store, can you also configure the events or maybe the streams of events or even segments of those events to not even go into the event store? I guess in that case, you're not even sourcing them to begin with. But if for whatever reason you want to source them, but get rid of them pretty quickly, I'm assuming you can configure that as well.
So in tier storage, you cannot. So it's really, really fixed on on all of the events. There's another feature that's also scheduled for the same release, which is event store transformation.
Oh, are we leaking into that one? Okay, all right.
So and that one allows you to be much more selective about what you do with events, and removal is one of the features.
Okay, we'll come back and talk about that one in a different session.
Exactly.
But great. So you also the last question, I hope. I always say last question, but then you never know. This feature is coming out sometime during the first quarter of this year. And what you explained is what we're expecting to come out in the first version of it. Is that correct?
That's correct, yeah.
And are we planning on bringing anything else into this feature in the future? Or is it based on the feedback we get?
Well, obviously, we always want to gather feedback. So in this first release, you might have heard me just say disk all the time. Yeah. Right? I'm talking about disk and from one disk to another disk. But there's other storage types than just disk out there. So especially useful for older events. We're also looking at storage buckets, right? The typical S3 if you're on Amazon, which is a very popular storage facility. And basically, you don't know where the data is stored. It's stored on some disk somewhere, but the cost of storage is really, really low for that. So you can really store an immense amount of data. The penalty there is on accessing the data. And we are looking at using those, let's say, cloud storage features for tiered storage as well, because they make sense, especially on the, let's say, the older parts of an event stream. It makes sense to just say, hey, S3 has them. If you look for them, then you pay a little penalty. You pay a bit of access cost to get to those events, but at least they're there.
Yeah.
And as long as you don't access them, then they're I guess they're cheap. And there's some technical challenges with that storage, because obviously we need to know what is stored where.
Yeah.
So we need some
Exactly.
index in some way to find them, and that is not easy in cloud storage. So we're currently looking into different ways to do that. So disk comes first,
Yeah.
and then at some point later in the year we'll have different storage classes as well.
Perfect. But I think business reasons as well, because we do have customers that are not allowed to use cloud-based storages and things like that. So this version of it is going to be very handy for them, I'm assuming.
Yeah,
So that's
absolutely.
really great. All right. So I'll come back with more questions when we have other features of this particular tiered storage feature that we have, and further on event transformation. So stay tuned. I'll come back.
All right.
Thanks
Thank
again.
You.
Right.
Bye.
Bye. Thank you for listening to my talk with Allard. Join me next time for other amazing talks with wonderful guests. Until then, have a great day and happy coding.